Hello gentlemen, welcome back. This video is on the law of cosines. We're actually going to break this up into two videos. This is the last topic that we have to cover for week 5, and it's actually not too bad. It's pretty straightforward, so let's get started. I want to start by looking at a triangle here. I'm gonna label, here's my angle A, side B, side C, angle B, and angle C. And here I'm going to just drop a perpendicular from angle C all the way across to side C. This little part here, I'll get my pen, is going to be X. This part right in here is going to be X right there, this distance here. And my height here of the perpendicular is Y. Okay? And what I'm going to do now is I'm going to look to describe different sides of the triangle. And so A, if I'm looking at A, and I'm looking at this triangle over here, from this point here down over like that. I'm looking at that triangle here, and I got a right triangle. This is a right angle here. This length right here, right there, is going to be C minus X, and that's where this comes in from. Okay, this is using the Pythagorean theorem. So this is my height Y, and so it's Y minus 0 squared. This is the side, the horizontal side of that right triangle, and it's going to be C minus X or X minus C. It doesn't matter because they're both squared. Okay. If I continue on there, I can square both sides. I get A squared equals X minus C squared plus Y squared, like that. And I can expand it out. And now what I want to do is I want to look at X and I want to look at Y, and I want to write them in terms of different sides of that triangle. Okay, let me get rid of some of this stuff here. Okay. And so if I do that, I can look at, and I can say X is equal to B cosine of A. So what I'm actually doing is I'm looking at the cosine of angle A. Let me write that out. Cosine of A is going to be equal to X over B. So X was equal to B cosine of A, like that. And I can do Y, I can say sine of Y is equal to Y over B, like that. And then I can say that Y is equal to B sine of A, like that. This should be an A. Okay? If I make those substitutions in, I got A squared is B squared cosine squared A minus 2BC cosine of A plus C squared plus B squared sine squared of A. I'm going to combine these two terms. If I do that, I get B squared cosine squared A plus sine squared of A. This is an identity here. That's equal to 1. Okay? And so what I get is I get A squared is equal to B squared plus C squared minus 2BC cosine A. So it looks a little bit like the Pythagorean theorem, but I have this other term because this is not a right triangle. Okay? Go through that derivation again if you have a little bit of problems, but this is the important part that we have. And here's a summary of the law of cosines. If I have the three sides and one of the angles, A squared plus B squared plus C squared, excuse me, A squared equals B squared plus C squared minus 2BC cosine of A. So this is going to help us when we're solving the different triangles. Again, so this is the different forms of the law of cosine. Remember, there were 4 different types of situations that we have in order to solve an oblique triangle. We've already looked at the first 2. We used the law of sines. The law of cosines, we're going to use the bottom 2. We're given 3 sides or 2 sides and their included angle. All right, let's do an example. Solve for the triangle. Here's a situation where I'm giving you all 3 sides, and now what I need to do is find the different angles. Let's start by solving for angle A. So we got A squared equals B squared plus C squared minus 2BC cosine of A. Let's solve this for cosine of A. If I do that, I'm going to bring the B squared and C squared term to the other side, divide by negative 2BC. If I plug in B is 3, A is 8, C is 9, I get cosine of A equals to 0.4815. I can use my calculator to find that angle A is 61.22. Okay, we don't have to worry about the ambiguous case here, like we did with the law of sines. Remember, when we use our calculator and we use inverse cosine, we're going to get an angle between 0 and 180 degrees. So we should be fine. Need to do the same thing to find angle B. Again, I solve for angle B. I get B squared minus A squared minus C squared over negative 2AC. Plugging in, I get 0.944. I get B is equal to 19.20 degrees. And then I can use the fact that all the angles in a triangle add up to 180 degrees to find angle C. So angle C is 99.58 degrees. Okay? Let's do one now when we have an included angle. So if I have a triangle with angle A is 55, B is equal to 3, and C is equal to 10, we want to find the other side in two angles. I can do this by starting by finding side A, okay, because I've got the included angle. This will be a straight plug-in right here. Take the square root of that side, and I'm going to get A is equal to 8.64. Again, B is 3, C is 10, and A is 55. Make sure your calculators are in degree mode, or else you'll be getting a different answer. I can do the same thing now. I can solve for angle B, okay, because I have all, now that I have side A. Again, it's a straight plug-in. I get cosine B is equal to 0.9586. I use second cosine. I get B is equal to 16.54. And again, to find the third angle, the easiest way is to use the sum of all the angles is 180. And so if I solve now for angle C, I get 108.46. Okay? Here's some practice right here. I want you to read 439 to 441. Here's some examples to look at. One's going to be looking at side, side, side. One's going to be side, angle, side. So you can see the difference. Here's some practice. These are pretty straightforward practice problems, simply using the law of cosines. No word problems in this one. We'll save those for the next video. So basically, fellas, this video covered law of cosines. It was an introduction to the law of cosines. Did a couple simple examples, and in the next video, we'll do some word problems and utilize the law of cosines. Okay? Have a good day.